Back, we are going to finish up this lesson on transformations within functions. So if we've got g of x equals f of x plus a constant, that means we are going to shift up that number of units. Whatever that constant is, we're shifting up that constant number of units. And if it's f of x minus c, then we are going to shift down. Okay, so both of these are the same type of transformation, and that is a vertical translation. Okay, so you shift up or down according to the sign. These two are also going to go together. So this time the difference is now that plus c and minus c are inside of this function. When it's plus c inside of the function, we go opposite the sign and we shift left. When it's minus c, we go opposite the sign and shift right. And that is a horizontal translation. So anytime you're adding or subtracting, it's a type of translation. Outside of the function is up or down, according to the signs. Inside the function is left or right, opposite the signs. Okay, these next two are going to go together. Okay, so we've got a constant times f of x. That means we're going to stretch by c units, or stretch c times, and it's outside of the function, so that is stretching vertically. And if it's times 1 over c outside of the function, we're going to stretch 1 over c times vertically. So when we're multiplying outside, that is a vertical dilation. Then we move that multiplication inside. Okay, and when it's inside, now this one, by the way, let's go back here. I said we're going to stretch 1 over c, but when we're doing this by a fraction like that, by a reciprocal, it's actually, what we're doing is shrinking. So here, when I multiply by c inside, I'm going to shrink by the reciprocal, 1 over c times, and this is horizontally. Okay, and these two are going to go together because here's another horizontal dilation. I'm multiplying inside by 1 over c. That is a stretch by c times horizontally. And that's a that's a horizontal dilation. Okay, so when I'm multiplying outside by a constant, I'm getting taller. By the reciprocal of that constant, it's getting shorter. When I multiply inside, it's getting narrower, but by the reciprocal of that constant, it's getting wider. When I multiply by a negative outside of a function, I'm going to flip over the x-axis. Okay, and that is a vertical reflection. When I multiply by a negative inside, it's going to flip over the y-axis. And that is called a horizontal reflection. When I take an absolute value of a function, what happens is I flip the negative y's over the x-axis. And when I take an absolute value inside, all the positive domain is symmetric about the y-axis. Okay, so a translation is any time you are adding or subtracting. A dilation is any time you are multiplying or dividing. Vertical is when it's outside the function. And you always take that number at face value. When it's horizontal, it's inside the function. And the numbers have the opposite effect. Okay, so when it's inside and you're multiplying, the dilation is by the reciprocal. When it's inside and you're adding or subtracting, it moves left or right opposite the sign. Okay, so write g of x that translates f of x down 3 and right 7. So g of x equals f of, and if I'm going to go right 7, it's going to be x minus 7 inside the function. And if I'm going to go down 3, then it's going to be minus 3 outside of the function. If I want to dilate 3 times vertically, that means it's going to be 3 times f of x. But I also want to go left 9, so that x is going to become x plus 9. And I want to go up 3, so after I'm going to have plus 3. Another vertical dilation, just like above. Dilation, vertical dilation by 1/2. So outside the function, it's going to be 1/2. Translating right by 2 is going to be x minus 2. Okay, so now I'm going to write an equation in terms of x. So it's going to be g of x equals, and instead of just writing f of x is going to be x cubed. So I want 2 times f of x minus 7. So that's 2 times x cubed. So this one's a cubed function, minus 7. So this will be a cubed function, twice as tall and shifted down 7 units. Okay, and then for our g of x is going to be negative 4 times f of x minus 2 plus 3. And the original function is x squared, and here I've got a minus 2 in that function. So f of x is going to become f of x minus 2. So that is x minus 2 squared. X minus 2 squared, first term squared, then double the product, so that's negative 2x, doubled is negative 4x, and the second term squared is plus 4. Okay, so f of x minus 2 is equal to all of that. So g of x equals negative 4 times x squared minus 4x plus 4 plus 3. So I've taken that f of x minus 2 and put its value right there. And this can be simplified to negative 4x squared plus 16x minus 16. And then I still have that plus 3. So I can combine like terms to negative 4x squared plus 16x minus 13.